Welcome to Energy Talks, a regular podcast series with expert discussions related to power system testing. My name is Scott Williams from the podcast team at Omicron, and I'll be your host. In this episode, we are going to discuss the topic of essential rotating machine testing. The reliable operation of rotating electrical machines, whether generators or motors, is essential for continuous power generation and critical industrial processes. However, defects resulting from operational stresses and aging can cause rotating machines to fail. A wide variety of electrical testing methods allow you to identify developing problems throughout a machine's service life. But which electrical tests are essential, and when should they be performed to assess machine condition? With me to discuss these questions is Fabian Oettel, Product Manager and Expert for Rotating Machines Testing at Omicron. Hi, Fabian. Thank you for joining us.
Hi, Scott. Hello, everybody. Pleasure to be here. Thank you for the invitation.
Definitely. Fabian, we know each other, so I would like you to tell our listeners about your experience in the field of rotating machine testing.
Of course. Well, I studied at Graz University of Technology and I did my master there. And afterwards, I started in the installation group of the R&D department of a manufacturer of large rotating machines.
Yes.
And then I joined Omicron and started as an application engineer in the technical support. And then I got the chance to become a product manager for this particular asset. And this was, I think, already 6 years ago. Yeah.
Okay. And you're based in Austria.
I'm based in Austria, yeah.
In Klaus.
In Klaus, in the headquarters of Omicron.
And also the home of our rotating machines testing laboratory.
Yeah, that's true. Actually, we have the nice possibility to perform all the measurements and all the tests which we are talking today as well in our rotating machines test room, where a real hydrogenerator and our bigger motors are installed.
Okay. So back to our topic of essential rotating machine testing. Yeah. Of course, there is a wide variety of tests that can be performed on motors and generators to assess their condition. Which types of tests are we focusing on?
That's true. Yeah, there are indeed many tests on motors and generators because, as you already mentioned, they are essential for reliable energy production as well for continuous industrial manufacturing. Therefore, people like to know the condition of the asset, of course. Normally, or the easiest start is basically a visual inspection, and then different diagnosis tools allow us to get a deeper look into the condition of the machine. And this can be either classified as mechanical, chemical, or electrical tests, which are commonly performed. Here on Omicron, we are focusing on electrical tests. Therefore, I would like to tell you more about them in this particular episode.
Okay, great. So are there any specific or essential electrical tests that should be regularly performed? And if so, what are they?
Well, we recommend to evaluate the stator winding on a regular basis during an outage of the machine, for example, or as a factory acceptance test. So starting with the DC insulation resistance test, followed by different AC high voltage tests. These can be power dissipation factor measurements, otherwise known as tangent delta measurement, PD or partial discharge measurements, and of course as well voltage resistance tests are very important from my point of view to be performed. They can trigger single spots which might not be seen by the other measurements. Of course, other tests can complete this picture, definitely. I mean, there's a lot of other tests as well. And to give you an example about it, we had the case that an operator had several older machines where the windings or the joints of the windings had been soldered but not braced. So it is known that such joints can become loose over time. And if these interconnections or these connections can become a bad contact, this spot heats up and can potentially damage the machine. And in this case, the operator, for example, performed a DC winding resistance measurement and was able to detect these potential hotspots, and he could fix it. So other examples are, rotor windings and stator core, where different issues can occur depending on the design of the machine, of course. For each of these components, there are possibilities to detect these potential weak spots at an early stage.
Yeah, so you mentioned the stator winding as the primary testing object. Why the stator winding?
Well, if we are talking about machine testing, our focus is on motors and generators with higher rated voltage levels. So this means that besides the temperature, the ambient and mechanical aging, the electrical aging plays an important role in these assets. It is proven and shown by many international investigations, publications, as well as standards, that the stator winding is a crucial element involved when it comes to machine failure. Of course, a machine is not only composed of the stator winding. There are other active parts which should be checked from time to time, depending on the design, condition, and the age as well of the machine.
Okay, and so there are various testing methods to do this.
Exactly.
When exactly should these tests be performed? After the machine reaches a certain age or already at an earlier stage? What do you think, Fabian?
That's a good question and an important question as well. From my point of view, the starting point should be a factory acceptance test where you can assess risks as well before the machine is put into operation. So not just at the factory itself, but also maybe after transportation, it is recommended to perform testing when the machine is installed. For example, we had once the case that several machines of the same type have been or should be installed in a production line, where the one with the worst test results could be placed or they have been able to place it in a less critical point of the production. That's also risk management from operator's point of view.
Okay.
A fingerprint measurement, that's the so-called fingerprint measurement, can be performed at this time as a reference for all the future assessments. Since we saw that trending over time of the same machine, the same asset, is the most powerful tool to detect a potential issue. Other interesting time is, for example, before the machine's warranty expires, in order to check whether there are problems in the design of the machine or not.
Okay.
And of course, sometimes it's not possible to have a fingerprint measurement right after the production of the machine or manufacturing of the machine. In this case, I would start as early as possible with a measurement and take this as a reference for all the future measurements. And then, of course, the interval or the frequency of testing is then depending a bit as well on the condition of your machine, on the age, and so on.
Okay, so even if you were to do a measurement and you determine that measurement results are showing something other than what the original fingerprint measurement showed, it doesn't necessarily mean that the machine's going to fail right away, but with regular measurements, you can follow the situation to determine when maintenance is required, for example.
Exactly. I mean, there's never a black and white answer for such questions, of course. It's always depending a bit on the situation, on the type of defect. You can really classify these types and then either assess it as a critical problem or issue which needs to be solved immediately, or as a problem or issue you can live for years, for example, as well. So as I said, there's never black and white, but these are normally the boundary conditions we are talking to answer these questions.
Okay. Fabian, you have mentioned a number of electrical tests, such as the power dissipation or power factor measurements, partial discharge measurements, voltage withstand tests, and DC winding resistance measurements. And of course, there are others. Are some of them redundant? In other words, could I skip some of them?
I was expecting this question. Yeah, thank you. Of course, you can skip some of them, but then you might miss important information.
Yeah.
I mean, it's always a compromise between time and the information you want to get. But there's a good reason why we recommend performing each of these tests, because some of them might indicate some issues where others cannot indicate these particular issues. So we had, for example, the instances where the power and dissipation factor measurement did not show any issues, but with the PD measurement, we discovered that the machine was in a critical condition. And this happens as well, vice versa. So, as I said, that's good reason why we are recommending all these tests. So, yeah, it has become good practice to rely your condition assessment on different testing methods in order to be sure that if there's a problem, if there's a problem, you send your machine to the repair shop.
Okay. So of these measurements, you spoke about partial discharge or PD as a measurement method. Can you tell me a bit more about that?
Yeah, sure. This is a very important, not just important, but as well interesting from my point of view measurement. So the PD measurement is a powerful tool to detect single weak spots also inside the insulation of the machine without dismantling the machine. And this makes it very, very attractive, basically. Problems in the insulation system, such as deterioration of stress layers, loose coils or bars, or simply aging of the insulation system, are issues which can be detected by the measurement. These are just examples. PD, the physics behind it is that partial discharges are small discharges which partly bridge the insulation system. This is where the name comes from. So it's just a very simplified explanation. These discharges result in small current pulses which can be correlated with the sinusoidal excitation voltage. And this afterwards results in the typical patterns, so the so-called phase-resolved partial discharge patterns, or PRPD. And according to these patterns, you can classify the origin of the issue as well as its criticality.
Okay. Is it difficult to interpret PD data or the PRPD patterns?
The next good question, which might brings me into trouble. No, I would say not really. Of course, at the beginning, if you're completely new on this field, it may require some training. But the critical patterns, they are known and verified by, again, international standards, international publications, investigations, and so on. So we know the shapes of critical patterns quite well. Additionally, we are offering automated source separation and PD interpretation tools to support here the user to a maximum extent. Okay,
so these tools are essentially helping users with the analysis of the PD data.
Yeah, exactly. That's the purpose of these tools.
Okay. Now, Fabian, you also mentioned prior the static core measurement. Tell us some more about that.
Yeah, sure. This is the newest CPC 100 measurement, basically, which the CPC 100 is our device which can perform nearly all the tests which we are talking in this podcast, except for the PD measurement. In this case, the CPC 100, in combination with the TD and the CR, acts as a high voltage source, but the measurement itself is performed with our MPD 800 measurement system. Now, with our stator core measurement upgrade option, the CPC 100 performs the stray flux measurements on the stator cores to detect weak spots in the insulation of the laminated core segments. So that sounds a bit complex, a bit complicated, but basically these laminated core segments are insulated against each other to minimize the eddy current losses. And once the insulation gets damaged, higher eddy current can occur. And again, then you have the problem of potential overheating of the stator core. So for this stray flux measurement, an auxiliary winding is used to excite the stator core to a few % of the rated flux. And then an air coil on an automated slide scans the surface of the core. And the nice thing from my point of view and convenient thing from my point of view is that the CPC 100 is able to perform both, so the excitation and the measurement. So any change in this stray flux is then indicating a potential weak spot. And this can be done with our new accessory there, together with the PTM, the primary test manager software.
And You mentioned the PTM software. That also has a number of convenience factors for users in performing nearly all of the tests you've been describing so far.
Yeah.
Could you say a few words about that?
Yeah, sure. With this software, we try to how to say, I would say we try to increase the convenience for the user. So PTM Private Test Manager not only offers a guidance to the test with connection schemes and so on, but it also shows you the results in a very nice way, and then it speed ups the reporting afterwards. So the post processing of the measurement becomes really short. So the time for post processing comes down to a minor thing. This is basically highly appreciated normally by the operators, because they always have the problem or the boundary condition basically to speed up the measurement to a maximum, or to really speed up the measurement to come that the costs are coming down to a minimum.
Okay. So just in summary, in performing all of the tests you recommend, it's key that you have maybe as few testing devices as possible, and that you have a software you can use to process the data from all of the tests for convenient comparisons and also reporting.
Yeah, exactly.
Okay.
So this was basically our intention behind it. When we are developing something new or we are adapting anything in our products, to have turnkey solutions for all of these measurements, and the possibility to combine everything in one device with, of course, with some accessories, but the CPC 100 in combination with the software can be done all of them.
Okay.
Can do all of them.
So Fabian, I have to ask you, of all the tests you described, do you have a particular favorite electrical test for rotating machines?
That's an interesting question. I haven't heard these questions before, so I haven't really thought about it. No, not really. I do not have a certain preference, as all of them are useful and can indicate a potential problem. Therefore, for me, all of them are important, and I do not have a certain preference.
Okay, well, that's fair. Fabian, this has been very interesting. Thank you for this overview and for your descriptions of essential electrical testing methods on rotating machines.
Yeah, it has been a pleasure as well for me, and thank you for the invitation. Thanks, Scott, and bye-bye, everybody.
Thanks again, Fabian. And a big thank you to our audience for listening to this episode of Energy Talks. We welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. Omicron has several years of experience in rotating machines testing and offers you the matching solution for your application. By the way, all of the tests mentioned in this episode are also described in detail in our guide, which is called Diagnostic Testing and Monitoring of Rotating Machines. You can download this guide from our website. Omicron Academy also offers you a variety of webinar courses on rotating machines testing. So be sure to visit our website for more information at omicronenergy.com. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.